Hello everyone and welcome to this another episode of 3D prototyping in Unity. My name is Kisanis. Guys, this is the first episode in our cinematography series. And I'm going through this series because I'm teaching a cinematography course for video games at Sheridan next semester. What I'd like us to do is I'd like us to start off by focusing on the Unity camera. I'm not going to be using any outside plugins or anything like that to do any of the stuff that I'm doing within this series. We're going to be doing everything with the basic elements of Unity. So I'd like to take a look today. I'd like to all start off today looking at the main camera. All right, let's get started. Okay, guys, so what I'd really like to concentrate on today is the camera. And we're really going to take a look at the camera and all of the options within the camera. I want us all along the same page as far as this virtual camera is concerned, as far as the default Unity virtual camera is concerned. I'm not going to be using any additional plugins, so there's a lot of things out there that are very, very powerful tools. Cinema Suite, for example, that will allow you to go through and make some really, really nice stuff. Now, I could cover that. I could cover Cinema Suite, but I've actually decided not to. After talking to several different studios in the area, not all of them use Cinema Suite. Some of them use other things. Some of them don't use anything at all. Some of them just use the basic Unity camera. So what I've just opted to do in this series is really focus on Unity, on the default objects within Unity, so that we can really get to know it, and then we can spread out once we have a basic idea of the Unity stuff. We can spread out to whatever existing tool is available within the studio you're going to be working at. Anyway, whenever you start off a brand new scene, you're going to end up with two things in the scene. We've got ourselves a main camera and a directional light. Both those will automatically come in as default whenever you start off a brand new scene. I've created a cube and a sphere for demonstration purposes. Those will obviously won't come in. The main camera is what I want to take a look at here. You can easily create multiple cameras simply by going to Game Object, going down to Camera, and adding in new cameras. But like I said, every scene will automatically start off with a main camera. We'll take a look at it and the differences between that and a regular camera when we bring it in. Now, whether you've started a 3D or 2D scene, it doesn't really matter here. We're going to be working within 3D space, so hopefully you've started yourself a 3D scene. And so we're moving around in 3D space, and we're going to be looking at what the effects of the perspective projection are, is what you'll end up with typically in 3D space. Anyway, let's take a look at what we start off with a main camera. First of all, it'll always be tagged as main camera when it starts off, and it'll remain on the default layer. It'll always be listed as a main camera as well. Now, each camera, regardless of which one you bring in, whether you start a new one or not, will automatically have the transform node and the camera node as well. The GUI layer, the flare layer, and the audio listener will be all things that we discuss later on in this series, but for now we're going to really concentrate on these two nodes, the transform and the camera node. Now, the transform node is very, very typical of most of our assets within Unity. It'll have some kind of transform node or ability to move it about anyway. The transform node basically allows us to move the camera around just like any other asset. So you can see that we can transform this along the X, the Y, and the Z. All right. It'll typically start off at the location of 0, 0, -10 whenever you start a brand new scene. Rotation will start off typically as all zeroed, but rotation is also available, so we can rotate our camera so we're looking at the location that we want to look. Okay, rotation in the X, Y, and Z plane are also available. Scale, however, will do nothing at all. So I can scale this up 3, 3, or 3, 4, and 6, and you can see there's been no effect at all in my game view or my camera preview, and no effect on the actual camera itself over here. So having these things here set in the scale will not do anything at all. So we're really in the transform node restricted to our position and our rotation. Okay, but our camera can be moved about in the same way as any other asset we've created within our Unity itself. It's exactly the same as, for example, this sphere. It has a transform node, etc. All right. There's a number of different things that we can actually see on the camera itself. We can see the camera frustum, which is located here. Whenever it's selected, we'll see the camera frustum. In 3D or in perspective projection, it will look like this. Okay, we'll take a look at that, how it changes when we move into the orthographic projection later on. Whenever we select our camera as well, we'll also see the view of that camera in this small camera preview down here. All right, and obviously we can see our main camera, or the camera that is being displayed, or the game itself, excuse me, down here in our game view. All right, so let's take a look at the camera option right here. Now, the camera node has a number of different variables here that we can either turn on or turn off, and they will affect the camera in many, many different ways. Starting off at the very top, we've got our clear flags. Now the clear flags has 4 different options. Let's just open it up here and take a look. We've got our skybox, solid color, depth only, and don't clear. 3 of these you will use fairly frequently. I myself have never really used don't clear, and I'm sure there's someone out there who is actually a camera expert that will tell you, oh, I use don't clear for this or don't clear for that. But let's go through what these options are. If we take a look in the background right here of our game, or in this camera preview, we can see that we are rendering out both our cube and our sphere. Now everything in behind the cube or the sphere is being replaced with this skybox, and that's what our clear flags option skybox does. It'll automatically fill in the complete depth with the skybox. Anything that has nothing rendering in front of it will have this skybox in the background. Okay. The second option is the solid color, and the solid color will also, you can go in there, you can change it any way you want. You can change it to red or anything else you want. The solid color will render in place of anything else. So if there's nothing that's being rendered, no cube, in this case we have our cube and our sphere, nothing in behind it, we're going to replace it with a solid color in the background. The solid color, if I have the skybox option on, if I don't actually have a default skybox, and we'll take a look at creating default skyboxes in a much later episode, if we don't actually have a skybox in place, it'll automatically move on to the solid color and replace everything with this background color. So if for some reason my skybox had been removed or etc., it'll automatically go in just like it would for the solid color and replace it with this background color. Okay, so that is the purpose of the skybox and the solid color. Depth only. Depth only basically will allow us, if we set depth only, here I'll do it right here, it will not place anything in the background. So if there's nothing in behind this sphere or nothing in behind this cube, it'll render nothing. There's nothing being replaced back here. And this is very, very useful for very particular things. So let's say you had a problem. I'll just give a quick example here. Let's say you had a problem with a weapon. You're doing a first-person shooter and you've got yourself a weapon. And whenever your weapon's in front of you, it's colliding with and crossing the boundary of a wall, let's say. Your weapon's able to go through the wall. And you want to avoid that. What you would do is create a second camera with a depth only option on with only that gun in place. And that way that gun will be rendered on top of everything else with nothing in behind it. And that way you'll end up with a weapon that'll never cross any of the other walls. That's pretty much how you do that. I know that's kind of a weird example. Maybe we'll take a look at that in a future series or a future episode here. That's depth only. And as I mentioned, don't clear. Don't clear basically means it doesn't clear any of the flag. It doesn't clear anything. So whatever it rendered in the frame before remains on the screen. And I'm not really sure why people would use this. I'm sure there's some kind of interesting effect that some people might have for their particular game. But I myself have never had a reason to actually use that option. Okay. After that, so we'll skip over background color. Background color basically associated with either the skybox or the solid color. After that comes our culling mask, and this is a pretty interesting one as well. I gave the example of only being able to see a weapon on a first-person shooter, only having the weapon visible to a certain camera. The culling mask basically determines what we see and what gets rendered. In this case, in the default case, we've got ourselves everything. However, we can go in and we can turn on or off certain things. So in this case here, it's rendering everything. Okay, let's say I don't want this camera to render out my sphere, for example. Well, currently, if we take a look at my cube is on the cube layer, and my sphere is on the sphere layer, and my camera is rendering all layers. Okay, this is looking at the layers. These are all the layers it's rendering. If I don't want my actual sphere to show up, I can turn off my sphere layer. And when I do, the sphere is no longer going to be rendered by this particular camera. Okay. Now, once again, there are reasons why you might want to do this. There might be things that you don't want to render at all to a particular camera. Let's say, again, we're taking a look at that gun example where we've got ourselves a first-person shooter, and we've got a main camera that's following behind the character, and we've got a separate camera that's just looking at the gun to make sure that gun doesn't go through walls or anything else. The only thing that the gun camera is going to render is the gun, and it's not going to render anything else. The main camera or the character camera is going to render everything except for the gun. Okay, so that's kind of why you'd want to do that. And as you can see that right here, the culling mask now says mixed. And you can turn on or off anything. You can have it render nothing at all, so nothing will show. In this case here, with nothing being rendered, it's only rendering my skybox. All right, I'll turn it back on to everything. Okay, so that is basically what the culling mask does. Right below the culling mask is our projection. And the projection basically has two options. We have the option of perspective and we have the option of orthographic. Now, whenever you start off a 3D project, you'll automatically come in with the projection of perspective. Perspective, as the name implies, will show perspective lines. So you can see that we can actually see the perspective in this cube. We can see that the cube is moving towards, if we trace these lines out, these lines are converging and they're moving to some vanishing point. If you are familiar with traditional art, for example, and you are drawing any kind of architectural or real lines, these lines will move towards a single point vanishing point. In this case, a single point vanishing point. All right, so these lines are converging. We see that with perspective. If we are in the case of orthographic, bang, we do not see any kind of perspective within the scene. So you can see I am seeing this cube, this cube, as if I'm looking at it straight on. Even though in perspective, we know this camera is slightly to the side of the cube, and we are actually able to see both sides, the front and this side here of this cube. In orthographic, we are not able to see that. We're seeing a front view only. Take a look over here as well. If we take a look at the frustum of the camera, in orthographic we have straight lines that go on, in this case, almost to infinity. It goes out there a million miles. And these lines are perfectly straight. They're perfectly straight. They maintain. There's no vanishing point at all. If we take a look at the perspective view, we can see that we are able to, these things here come from a particular point and they branch out. And that's what gives us our perspective. Okay? That's the difference in the two. Now, a lot of people will say, oh, perspective is used for 3D and orthographic is used for 2D. And a lot of times, orthographic is used for 2D. That is very true. We'll get rid of perspective when we're doing a lot of 2D games, especially when we're doing 2D games that are actually only sprites. I, however, like to use a perspective camera even for my 2D games. And the reason why I like to use it is it gives me the illusion of depth. So I can actually get the sense of movement from a perspective camera that you will not get from an orthographic camera. If you're interested in seeing what I mean by that, I did in my first series, my 2D series, one of the first videos is called Free Parallax, and you could watch that video to understand why I use a perspective camera over an orthographic camera, even for my 2D games. Most of the time. Now, below the projection is this field of view. And a lot of people think that the field of view is actually referring to the camera's focal length. A lot of people say, "Oh, this is a 60 millimeter camera," and it's not. It's not actually referring to anything to do with focal length of your camera at all. What this field of view is telling you is the vertical view that you are seeing within your camera. Okay, if I increase this, I am increasing my vertical distance that my camera is able to see. Take a look at this frustum over here. If I lower it, the vertical view is getting smaller, and if I raise it, the vertical view is getting much, much taller. Now, in some ways, it is acting like a focal length will in a typical lens. The focal length of a typical lens, depending on what, if you're using a wide-angle lens like an 18 millimeter or a 24 millimeter, something like that, you are a fisheye lens or something like that, you're going to get a very, very wide field of view. And you could see that all the objects in my screen appear to move back farther away from me as I increase this field of view. And as I decrease the field of the view, the objects appear to moving closer to me. And that acts very much like a longer lens, a 300 millimeter lens or something like that. However, this is not referring in any way to a focal length. It is just the vertical height that you are seeing. It is not the actual horizontal height is being affected by my actual resolution here. So in this case here, if I have a 5x4, I'm seeing this much. If I have a 16x10, I'm seeing this much, etc. It's widening out my horizontal view. This field of view is really referring to our vertical view, and the default is 60. It'll come on at 60 at first. Okay. There's two different kinds of distortion that you can get from changing the lenses. And like I said, lots of people associate the field of view with a focal length of a lens. And depending on what kind of lens you're using, you're going to get different types of distortion, lens distortion or perspective distortion. Everything will get perspective distortion, but depending on the type of lens that you're using in a real life camera, you will end up getting some distortion caused by light traveling through a convex lens. The light is bent when it goes through the convex lens. It's bent towards the sensor, and that causes the straight lines within an image to appear wavy or to appear bent or squeezed in. There's a number of different distortions that can occur in a real life lens. By playing with the field of view, you will not get any kind of lens distortion. It doesn't in any way affect the straight lines within your image. Okay, so you don't have to worry about anything like that if you're playing with the field of view. You will still, however, get perspective distortion. Perspective distortion is basically things that are closer to the camera appear larger. So in this case, where we've got ourselves a cube and a sphere that are approximately the same size, the sphere in this case appears larger because it's closer to the camera. And you guys see that every day. You know, you look in the background and you see buildings that are far away and they look really tiny and etc. You guys have seen that every day. But that's called perspective distortion. And of course, in a 3D situation, in a perspective situation, when we're taking a look at a perspective camera, we are going to have perspective distortion. Okay, so let's put our sphere back where it was for now. Let's put it at 0. This was at 0. No, this was at 0. This was at 0, 0. And this was somewhere like this. All right, let's just put it back kind of like that. Anyway, guys, let's go on to our clipping planes. That's what we're moving on to. The clipping planes. Now, typically, they'll start off as 1,000, 0.3 for the near, and 1,000 for the far. Now, basically, the clipping planes, you can see the clipping planes here on this camera. Basically, this far edge and this near edge. This near one next to my camera is the near clipping plane, and this one at the end of my frustum is the far clipping plane. Any objects that fall within this frustum will be rendered out. Okay, so by changing, let's actually change our sphere again. Let's move our sphere back. Let's say to there. Let's go into our main camera and let's change. First of all, just change it to 100. When I change it to 100, you can see that the far clipping plane has moved closer, but both my sphere and my cube still fall within that frustum, and I'm able to render both. I'm still able to see both down here. If I change my far clipping plane to, let's say, 10, now the only thing falling within that frustum is the cube, and I'm no longer able to render my sphere. My sphere is outside, and I'm not rendering it at all. All right, so determining how large your near and far clipping planes are will go a long way in determining exactly what is rendered. Actually, it'll go all the way in determining what is rendered. All right, and the near one can be moved in exactly the same way. You can move it farther or nearer to your camera. Okay. Below that is our viewportRect, and our viewportRect basically determines where on the screen our camera is rendering to. It's rendering to start off with a full screen camera, so this is our screen space. It has a value between 0 and 1. 0 meaning the upper one corner, and the nothing, and 1 meaning the full. Okay, so in this case here, where we are starting at a height of 0, or a y of 0, and it goes to a height of 1, we're rendering to our full height of our screen. So you can see that right here, we're running to the entire height of our screen. If, however, I decide to change this, so let's say 0.5, now you can see right down here in my game view that I'm only rendering to half of my screen. Only half of my screen is being utilized. And you might say, well, why would you want to do that? Why would you want to do that? There are a number of different reasons why you might want to change the viewportRect. Let's say you were doing split screen. You could have one camera being rendered on top, one camera being rendered on bottom, right? Then you've got suddenly multiplayer split screen. That's how it's going to work. One camera is only rendering up here, one camera is only rendering down here. And that's how basically that would work. Okay? You could use this as well to make a picture-in-picture kind of thing if you want to do something like that as well. We'll take a look at that a little bit later on. We'll take a look at some examples later on why you want to do this. I'm afraid this is going to end up being a quite lengthy video. I'm starting to have that fear. This is going to be a lengthy video. There's a lot of information I want to get to you guys. It's not a super exciting video. We're not doing a lot of code or anything like that. I just want to make sure we all know exactly what we're talking about as far as this camera is concerned. Below that, we've got the depth. And the depth is referring to the order in which a camera is rendered. Lower numbers are rendered first, and higher numbers are rendered last, meaning the higher numbers are rendered on top of the lower numbers. Okay, so if I've got a camera that's located at -1, that'll be rendered. And if I have a camera that's located at 10, that'll be rendered next. And you might say, well, again, why would you want to do that? Why do you want to have them render on top of each other? Well, once again, if we take a look or we think about our first-person shooter that I mentioned earlier, what you'd want to do is you'd want to have the character's camera, so everything the character is seeing, rendered first as the background. On top of that, so let's say that camera have a depth of -1. On top of that, you'd want to have your gun camera, and the only thing being shown in your gun camera is the actual gun itself. But you want to make sure that gun is always rendered on top of everything else. So you'd give that camera, that gun camera, which only is showing the gun, have a depth of, let's say, 2 or 10 or anything up to 100. So it's always rendered on top of your player character's view. Below depth is rendering path, and Unity supports a number of different rendering paths. We're not going to talk at all about it really, just leave it on use player settings, but basically you will set your rendering path based on your target platform. I'll leave it at that. Below that is target texture. Now, target texture allows us to render, instead of to the screen, to a particular texture. And if you'd like an example, in the initial video I showed, my character runs past a number of different computer consoles that have a screen, and it shows my character running back and forth on the screen. And basically what I do there is I set a texture to an asset, and that texture will automatically show what the camera sees. And that's how I created that computer screen. All right, we'll take a look at a really good example of target textures in a later video when we actually build that asset. Below that is occlusion culling. Occlusion culling allows Unity to not render anything that's occluded or hidden behind other objects. So if you have something that's completely hidden behind a wall, it will not render it, thus saving you processing power. HDR. Now HDR stands for High Dynamic Range Rendering, and high dynamic range rendering is useful for a lot of different things. It's much more processor intensive. Now, basically, what happens is the values for any given I just touched the mic. Sorry. Any given texture have a value between 0 and 1, where 1 it being the nothing, being darkness, being black, and 1 being the highest value for a given channel. And a lot of times, if we want to turn up things so that they're blown out or whatever, using HDR will allow us to bring those values back into a value between 0 and 1. So colors will not be lost in any high intensity areas we've got on the screen. So like I said, there's a couple of advantages to it. You're not going to lose the high intensity areas. You get a nice bloom and a glow out of it. It supports both bloom and glow. And you can reduce the banding that's often caused in low frequency lit areas. There's a number of disadvantages as well to HDR. First of all, it uses floating point render textures, so it's going to be slower. You can't use anti-aliasing. Like if I turn on HDR right here, it'll give me a warning saying I can't use anti-aliasing. There's a number of different things. We're not going to be concentrating on HDR within this series a whole lot. If you guys are interested in it, I suggest you maybe watch one of the other videos that actually are concerned strictly with HDR. Alright, the last thing in this entire section is the target display. And basically the target display, there's up to 8 displays that this can be shown on, and what it allows you to do is determine where a camera renders to, whether or not it's rendering in the main display, so for example on my display 1, which is this monitor here, or on an entirely different location, another monitor entirely. Alright, that's what this target display allows us to do. Oops, let's turn that off. Anyway, alright guys, so that is the basic camera, and I know that's a lot of information I just threw at you. I think this video is going to be long and kind of boring. I'm really sorry. Okay, let's very quickly look at a couple of examples of multiple cameras within our scene. We're going to take a much more in-depth look at that when we start creating our assets and actually start creating the game that you saw at the beginning. But for now, we've got ourselves our main camera. If I want to add another camera to the scene, it's very easy. Game object, go down here, and I can either duplicate this guy here, or I can come down here and say camera, and it'll automatically create for me a new camera. Let me just zero this camera out so it is somewhat near. I'll actually put it right with our oops, that should be minus 10, right next to our, and I'll move it over a little bit, right next to our main camera. So right now we've got two cameras in the scene right there and there. All right. Here's our main, and here is our other one. And you can see that the camera preview will match whichever camera I have selected at the time. So right there and right there. A slight difference in the two. Okay. The new camera I brought in is slightly different than the first one. It is listed simply as camera, and it is untagged. All right, our main camera has a main camera and tagged with main camera. The other difference is the depth that this came in at. It came in at a depth of 0, which means our main camera will always be rendered first, and this camera will be rendered second. Now, there's a couple of things that maybe I want to do. Let's say I didn't want my main camera to be able to see the sphere for some reason. How would I go about having the other camera see the sphere? Remember, I gave the example originally of having it be a gun in a first-person shooter. Let's pretend the sphere is our gun, and we want it always drawn on top. Well, it's very, very simple. The first thing we're going to do is we're going to go to our main camera, and we're going to make sure that our culling mask does not have the sphere layer. So right now with this camera preview, I'm only seeing the cube. Down here in the game view, I'm still seeing both the sphere and the cube. And the reason why I'm still seeing both is because our main camera has a depth of -1. It's being drawn, and then our other camera is being drawn afterwards at a depth 0 and drawing everything on top. Now we don't want that to happen. All right. The only thing we want is for our camera, our second camera, to show the sphere. Okay, so if I want that to occur, I'm going to come down first of all, and I'm going to turn my clear flags to depth only. So first of all, right away, what we're seeing is we're seeing this camera I've got selected here is seeing my sphere and my cube, and my main camera is seeing simply the cube and the background. So I'm only drawing this first camera is only drawing the sphere and the cube, and this main camera at the back is only drawing the background and the cube. Now, last thing I want to do with this camera here, if I only wanted to see the sphere, I'm going to turn it depth only. I'm going to go down into my culling mask and put it on nothing, or I'm simply going to turn on just my sphere layer. Now, with this camera selected, I'm only drawing this camera here, and everything else is being drawn. This looks like our original view. If I move around my main camera, watch my game screen down here. If I move around my main camera, you can see that the sphere is staying in place. It is being drawn on top of everything else. Okay, so let's say that our sphere and our cube were individual characters. We're going to want to make a different thing here. Let's put our sphere in the middle. I'll put our cube in the middle, and we'll put our sphere in the middle here, just approximately. Okay, let's say that we want to make a split screen game. Once again, very easy. I want to reset my camera. I want to reset my camera so that is only seeing, so it's not only depth only, it's seeing my skybox. And once again, I want it to see my sphere. Now, it's going to be moving around with my sphere. All right? It's going to be moving around with my sphere. Now, let's say actually, I won't go through. Actually, I will do this. I'll take my camera, and I'm going to drag it, and I'm going to drop it inside of my sphere, inside of the hierarchy. So now when I move my sphere around, my camera moves with it. Okay? And I'm going to turn it back to everything instead of, I'm going to turn my camera back to everything instead of my culling mask. So it's back to everything. All right. I'm going to go back to my main camera, and I'm going to turn it to everything as well. Okay. So right now, again, I'm drawing my camera on top. This camera is being drawn on top. It's at depth of 0, so I'm seeing both my sphere and my cube in there. All right. If I actually move around my sphere, you can see that my cube is moving around. Now, in order to create a split screen, all I have to do is change the location that my camera is rendering to. Let's say I decide to render this at 0.5. All right, it's showing down at the bottom. Let's go to my main camera, and we will change this. Instead of being at 0, let's make this 0.5. So now we've got our top and bottom. We've got our split screen. Let's drag our main camera and drop it on the cube. Drop it on the cube. If I move my cube around, boom, 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 you can see that the camera itself is moving with the cube in this case. In the top case, it's moving with the cube. And in the bottom case, down here, my camera is moving with my sphere. All right, so that's how you'd go about creating a split screen. Now, lastly, let's say we didn't want this. Let's say instead we wanted to create some kind of overhead camera. Let's say we wanted that instead. Let's take a look at how we do this. Let's create a plane. Let's go create game object. Let's create a 3D object, a plane. We're really quickly here, and I will make it large. Let's make it, let's first of all set it to 0, reset, drag it down a bit so all our stuff's sitting on top, and let's make it 10 and 10, like that. I made that 109. Let's just make it 10. All right, so right now we can see that in both cameras we've got ourselves this infinite plane. Let's break this up again. I'm going to drag my camera out so it's no longer attached to that, and I'll leave my one attached to the cube here. So right now we still have our camera that's attached to this cube, and the other camera is not attached to anything at all. Now let's say what I wanted to do is, instead of creating a split screen, I'm going to set this back so it's at 0. And I want to make an overhead map. Let's say I want to make an overhead map. I'm going to go down to this camera right here, and I'm going to, instead of using a split screen, let's make this at a height of 0.25. All right, and let's make this a width of 0.25. So you can see right now, right down here in the corner, I've got myself a little mini map. Let's make this a little bigger so we can see it. All right, and all I have to do, let's say I bring this up like this. I'll bring it way up overhead. I'll rotate it down so it is facing downwards. 90 degrees. All right, there's my camera. Let's move it up on top so it's not fully rotated. Where's my global? I hate it when it does this. Let's move it up here like this. All right, and we can see right now this thing is seeing an overhead view. Let's say I took this camera and I dragged it and I dropped it right on top of my cube again. Whenever I move my cube around down here in the corner, it's kind of difficult to see, unfortunately. Let's change the color of this. Let's change the color of this. Can I change the color of it really fast? Where's my project? Where's my project? I'll have to change everything. I'm not going to bother changing it. But right down here, you can see that I've got myself the cube. Let's make this bigger. I'll make it much bigger so you guys can see it. Come on, grab it. Hate this. Ugh, got it. All right. So right down here in the corner, we can see that I've got my overhead map. If I actually move my cube around, all right, you can see that my overhead map is updating as well. All right, so I've got an overhead map down here in the corner, and of course you could surround that with a nice gooey border or whatever, so it's far more noticeable than I've made here, and we've got ourselves a character that can move about in space. All right, and we've got ourselves a nice overhead map. That is a couple of applications of multiple cameras. Anyway, guys, I hope you enjoyed that episode. I know it was long and it was kind of boring. But I really wanted to make sure that we all started off in the same place as far as knowing how the cameras work. I hope you guys enjoyed it. I hope you learned something. If you did, let me know in the comments. Let me know with a thumbs up if you liked it. A thumbs down is perfectly fine. It tells me how I can change. Make sure you have a comment that says, hey, I hated it because you didn't do this, you didn't do that. That way I can change. I can help you guys out. All right? Thumbs up, thumbs down, comments down below. And if you haven't done so, please take a few seconds to subscribe. Have yourselves a wonderful day, everyone.